You think you understand your electric bill. Every month you pay it, kilowatt hours, you've seen the number thousands of times. Fine. Explain it to me. Why kilowatt hours? Why not just kilowatts? What's the hours doing there? Most people shrug. That's just how they measure electricity. But that's not an answer. That's admitting you don't know. Here's what should bother you. Watts already measure electricity. Your light bulb says 60 watts right on it. Your microwave says 1000 watts. So why does the power company insist on multiplying by time? Because they're not selling you what you think they're selling. Your electric bill doesn't charge you for electricity at all. It charges you for times time. Specifically, for how long you borrowed energy from spinning generators hundreds of miles away. The difference between watts and watt-hours isn't technical jargon. It's the difference between time speed times and times distance, between times ability times and times accomplishment, between potential and reality. And once you see it, you'll understand energy is felt differently. Let me show you. The standard explanation goes something like this. Kilowatt hours measure how much electricity you use. You might have learned it in physics class. You might have nodded along when someone explained it. It's not wrong exactly, but it's empty. It's like saying miles measure how far you went. True. But it explains nothing about times, why times we needed a separate unit from speed. Here's what nobody tells you. There are two completely different questions hiding inside your electric bill. Two questions that most people smash together into one because they've never been forced to separate them. Question 1. How times powerful times is this device? Question 2. How much time, work times, did this device actually accomplish? Those sound similar. They're not. They're as different as how fast can you run and how far did you run today. And the kilowatt hour, that strange hyphenated unit everyone ignores, exists specifically because the power company needs to answer the times second times question, not the first. They don't care about your capability. They care about what you actually did times with the energy they sent you. The distinction sounds technical. It's not. It's the key to understanding everything from why your phone dies to why power plants exist. Let me show you what I mean. Start with something simple. Pick up your phone. Look at the battery settings. Somewhere in there you'll find a number measured in milliamp hours. Maybe 3000 milliamps. Maybe 5000. Now ask yourself, why milliamp hours? Why not just milliamps? You've seen this unit your entire smartphone owning life. You've compared phones by it. You've bragged about it. But have you ever actually understood what it means? Here's what's actually happening. Milliamps measure how much electrical current flows through a wire at any given moment. It's a times rate, a speed, how much charge passes a point every second. But your phone battery doesn't care about speed. It cares about times capacity, how much total charge it can store and release before it dies. So we multiply by time. If your battery can push 3000 milliamps for 1 hour, or 1500 milliamps for 2 hours, or 500 milliamps for 6 hours, it has 3000 milliamp hours of capacity. Same total amount, different rates, different duration. Stop and think about that. The milliamp tells you how thirsty times your phone is right now. The milliamp hour tells you how much times water times is in the tank. One is instantaneous, the other is cumulative. One describes the present moment, the other describes a total journey. This is the same distinction that separates watts from watt-hours, the same distinction that separates horsepower from how far your car actually travels, the same distinction that separates times ability times from times accomplishment. Your phone manufacturer understands this. That's why they don't advertise milliamps. Milliamps alone would tell you nothing about how long your phone lasts, and your power company understands it too. They don't care how many watts your appliances times draw. They care how much total energy you actually consumed over the billing period. But that's just the surface. Because if this is just about rates versus totals, it raises another question. A watt is not a measure of electricity. Not really. A watt is a measure of times power. And power means one very specific thing in physics. Power is the rate at which energy transfers from one place to another, not energy itself. The rate times of energy, how fast it flows, how quickly it moves from source to destination. 1 watt equals 1 joule of energy transferred per second. That's the definition. Carved in stone. A 60-watt light bulb transfers 60 joules of energy every second it runs. A 1,000-watt microwave transfers 1,000 joules per second. Think about what that means. Watts describe and times, instantaneous times reality. Right now, in this moment, how much energy is flowing through this device? That's what wattage tells you. James Watt figured this out in the 1780s. He needed to describe how quickly his steam engines could do work. Not how much times work they'd done, but how fast times they could do it. He compared his engines to horses. How many horses would you need to match this engine's output rate? That's where horsepower comes from. Another rate. Another measure of how fast energy moves, not how much has moved. But here's the thing that should bother you. Rates are meaningless without duration. Saying your car goes 60 miles per hour tells you nothing about where you ended up. Did you drive for 1 minute, 1 hour, 10 hours? The rate alone is useless. Saying your microwave draws 1,000 watts tells you nothing about how much energy it consumed. Did it run for 10 seconds, 10 minutes, 10 hours? The rate alone is incomplete. So how do we capture the times total? Here's where it gets interesting. To know how much times actually transferred, not the rate, but the cumulative total, you have to multiply rate by time. Speed times time equals distance. Watts times time equals energy. If you drive 60 miles per hour for 2 hours, you've covered 120 miles. If you run a 1,000 watt microwave for 1 hour, you've consumed 1,000 watt hours. 1 kilowatt hour. That's it. That's the whole secret. Kilowatt hours aren't some arbitrary utility company invention. They're the mathematical result of multiplying power by duration. Rate times time equals total. And that total, the energy, is what actually matters in physics. Energy is the capacity to cause change, to heat things, to move things, to lift things, to transform things. Energy is what the universe runs on. Power is just how times that energy flows. Important? Yes, but ultimately secondary. Here's a thought experiment. A lightning bolt can deliver about 1 trillion watts of power, 1,000 gigawatts, more than every power plant on Earth combined in that instant. But it lasts about 30 microseconds. Do the math. 1 trillion watts times 0.00003 seconds equals roughly 30 million watt seconds. Convert to kilowatt hours, about 8 kilowatt hours. 8 kilowatt hours. A lightning bolt, the most dramatic electrical event most people ever witness, contains roughly the same energy as running your air conditioner for an afternoon. Let that sink in. 1 trillion watts sounds terrifying, and it is in that fraction of a second. But total energy? Your refrigerator accomplishes more work by Wednesday. Power impressive. Energy times accomplish it. The power company knows this. They don't care about the momentary rate. They care about the accumulated total. That's why they bill in kilowatt hours. But we're not done. There's another layer. If energy is what actually matters, why do we even talk about power at all? Now we're getting to the core. Power and energy aren't separate concepts that happen to be related. They're two faces of the same underlying reality connected by time itself. In calculus terms, power is the derivative of energy with respect to time. Energy is the integral of power over time. If you don't know calculus, here's what that means. Power tells you the slope times at any moment. How steeply is energy accumulating right now? Energy tells you the times, area times underneath. How much total has accumulated over the journey? Same relationship as speed and distance. Same relationship as income rate and total savings. Same relationship as water flow rate and total water in the bucket. This isn't some special property of electricity. This is the fundamental structure of how quantities relate to their rates. And here's what nobody tells you. Every unit with hours or seconds built into it is capturing this exact relationship. Watt-hours, amp-hours, kilowatt-hours, Newton meters per second becoming plain Newton meters. The per time in the rate gets times cancelled, times when you multiply by time, leaving you with the pure accumulated quantity. Power, joules times per second. Time, seconds. Multiply them, the seconds cancel. You're left with joules, pure energy. Kilowatt hours are just joules, wearing a more convenient costume. 1 kilowatt hour equals exactly 3,600,000 joules. We use kilowatt hours because the numbers are more manageable for household billing. But underneath the unit conversion, you're still just counting joules, still counting energy, still measuring the total times, work times that was accomplished. And here's what that means for your electric bill. Every month, the power company sends you a statement that says, here's how many joules of energy flowed from our generators into your home. Here's how much times, work times was done on your behalf. Here's what you owe for that accumulated accomplishment. Not capability, not rate, not potential. Accomplishment. In your normal experience of the world, you think you're buying electricity. You flip a switch, lights come on. You plug in a device, it charges. Electricity flows into your home like water through a pipe. And at the end of the month, you pay for the electricity you use. Simple, intuitive, makes perfect sense. Except that's completely backwards. You're not buying electricity. You're not paying for electrons. The electrons in your home's wiring don't come from the power plant at all. They were already there. They've been there since the wires were installed. What travels from the power plant isn't matter. It's times energy, a wave of electromagnetic force that pushes the electrons already in your wire. Those electrons barely move. They drift at about 0.01 centimeters per second. A snail is faster, but the times, energy times, the push, the force, the capacity to do work that propagates at nearly the speed of light. So what are you actually buying? You're buying times time. Specifically, you're renting access to spinning generators. Somewhere, maybe hundreds of miles away, a turbine is rotating. Steam from burning coal, falling water, wind pushing blades, splitting atoms. Something is spinning a massive magnet inside a coil of wire, creating electromagnetic force. Every kilowatt hour on your bill represents 1 hour during which you borrowed 1 kilowatt of that spinning generator's capacity. Think about what that means. Every time you turn on a light, you're not consuming a substance. You're placing a demand on a distant spinning machine. You're asking a turbine hundreds of miles away to push a little harder, to maintain its rotation against the new load you just added. And the power company measures exactly how long you place that demand, at what level of intensity, and charges you accordingly. Not for stuff, for times duration times intensity. Your electric bill is a rental invoice for access to rotating machinery. Let me prove it. The entire electrical grid has to balance supply and demand in real time. Not because electricity gets stored up somewhere, but because power generation must exactly match power consumption at every instant. There is no warehouse of kilowatt hours sitting somewhere. The energy flows times as it's generated. When you flip on your air conditioner, a power plant somewhere burns slightly more fuel in that same moment. When you turn it off, they burn less. Your kilowatt hour measurement isn't counting the substance that flowed into your home. It's counting how much times work times distant machines did on your behalf and for how long. Pause. Your electric bill doesn't charge you for electricity. It charges you for times accomplished work. Times measured in how much power you demanded, multiplied by how long you demanded it. Not a commodity, not a substance, a service rendered, a labor performed, measured in the only way that makes physical sense. Rate times duration. Now, here's what people miss when they learn just about electric bills. This isn't about utility. This isn't about billing conventions. This is about the fundamental structure of how the universe tracks accomplishment. The same distinction, rate versus accumulation, appears everywhere. Your car's engine produces horsepower. That's a rate, a measure of how quickly it can do work. But the odometer measures miles traveled. The fuel gauge measures energy consumed. Accomplishment, accumulation. The integral over time. Your salary is a rate, dollars per hour, dollars per year. But your bank account holds accumulated wealth. The total, what you've actually times gathered, not how fast you gather it. Your heart beats at a rate, 60 beats per minute, 70, 80. But what matters is the total number of beats over a lifetime, the accumulation, the work done. Calories work the same way. A calorie is a unit of energy, not power. When nutrition labels say a food contains 200 calories, they're telling you the total energy stored inside the accumulation. When fitness trackers say you're burning 500 calories per hour, they're measuring power, the rate of energy expenditure. Same distinction, same relationship. Rate times time equals total. You're not separate from this. Right now, inside your body, mitochondria are converting chemical energy into mechanical work, heat, and electrical signals. Your metabolism is measured in watts, about 80 to 100 watts at rest, roughly the same as an incandescent light bulb. Over the course of a day, you consume about 2,000 kilocalories. That's 2.3 kilowatt-hours of energy. Your body is an electrical bill happening in slow motion. The food you eat isn't fundamentally different from the fuel spinning a distant turbine. Both are stored chemical energy, released over time, measured in the same units, governed by the same physics. When you eat breakfast, you're loading energy into the system. When you think, move, breathe, and live, you're spending kilowatt hours. Your heart is a power plant. Your muscles are motors. Your metabolism is a monthly energy bill that you pay in food instead of dollars. The kilowatt hour isn't just a strange unit on your utility statement. It's how the universe measures time's work done, how physics tracks time's accomplishment, how reality distinguishes between what something times could times do and what it times actually did. And that distinction, that gap between potential and reality, between rate and accumulation, runs through everything. Your electric bill just happens to make it visible. So, why does your electric bill measure kilowatt hours instead of kilowatts? Because kilowatts tell you nothing about what was actually accomplished. Kilowatts describe capability, potential, the times, rate times at which energy could flow at any given instant. But rate without duration is meaningless. A lightning bolt proves that. 1 trillion watts for a microsecond accomplishes less than your toaster does in a morning. Kilowatt hours describe reality. Accumulation, the actual work that was done on your behalf by spinning machines hundreds of miles away, integrated across every second of the billing period. Your power company doesn't care what you times could times have used. They care what you times did times use. And the only honest way to measure that is rate multiplied by time. But understanding this isn't just about electric bills. It's about understanding the difference between potential and accomplishment, between speed and distance, between what something times is times and what something times does. 200 years ago, nobody understood this clearly. James Watt was comparing steam engines to horses, trying to quantify something humans had never properly measured, the rate of doing work. The idea that work could be divided by time, that energy transfer had a time speed, times was revolutionary. Now we use it every day, without thinking. Every battery rating, every utility bill, every engine specification, every metabolic calculation, all of them depend on the distinction between power and energy, a distinction that exists because the universe doesn't care about capability. The universe only tracks accomplishment. The fact that we can measure this, that we can quantify work, integrate power across time, and bill each other accurately for energy consumed represents something profound. The universe is not mysterious. It is times accountable. Every joule can be traced. Every kilowatt hour can be counted. That's not trivial. That's extraordinary. That's what your electric bill really is. Not a confusing unit designed to trick you. A precise measurement of work performed. A record of accomplishment rendered in the only language physics understands. Not convenience. Not convention. Truth. If this journey into kilowatt hours changed how you see that number on your monthly bill, subscribe and share it with someone who still thinks they're buying electricity. What other everyday units hide this kind of depth? Calories, horsepower, decibels? Tell me in the comments what measurement you've never actually understood. Because once you start looking, you realize every unit is a window into how the universe actually works. You just have to ask what it really means.